Welcome to the lesson about the multiplication properties of exponents. Now, before we begin with the three properties that we're going to cover in this lesson, I do want to take a second to go back over a couple key vocabulary terms that you'll need to know. So when we are dealing with exponents, and I'll use this example over here with the threes, when we're dealing with exponents, remember an exponent, or sometimes called a power, refer to the small numbers up here. So in this case, it would be the 2 and the 5. The large number down below that's going to the exponent is referred to as the base number. So you have a base number, which is the large number here, and then the exponent, which is the smaller number to the upper right. Now, in general, what you want to remember, just as a refresher, any number to an exponent means that's how many times you will multiply the base number. So looking at just this piece here, 3 to the 5th power, that means we would have 3 times 3 times 3 times 3 times 3. Or down here, if I look at a 5 to the 3rd power, that means 5 times 5 times 5. So just a brief refresher on exponents and general vocabulary terms related to them. Then we are going to look at today's goal, which is to use properties of exponents, in this case specifically multiplication properties. And we have three different properties we're going to look at. The first property is the product of powers property, which an example of that would be a to the m times a to the n equals a to the m plus n. So basically what the product of powers property is telling us to do is if we have the same base number going to two different exponents, we can add the exponents. So our example here, if we had 3 to the 2nd power times 3 to the 5th power, that is the exact same thing as 3 to the 7th power, because we can add 5 plus 2, our exponents. So the product of powers property, if it's the same base number, different exponents being multiplied, we add the exponents. Our second property is the power of a power property. Now in this case, that means we only have one base number, or a base term, going to an exponent, and then it is going to another exponent. So in this case, what the rule tells us we can do is we can multiply the exponents. So our example would be if we had something like 4 squared in parentheses raised to the 3rd power, so 4 squared to the 3rd power, the rule tells us we can multiply the 2 and the 3, which would give us 4 to the 6th power. And the third rule that we're looking at, or third property, is the power of a product property. So that means if in parentheses we have two different bases being multiplied, and they're going to the same power, or the same exponent, we can split them so that each number goes with the exponent. So we would split it from a times b in parentheses to the m, and it could be a to the m times b to the m. Now this power is the most common one that we'll use when we are doing the final steps of simplifying different expressions. But the reason that we have this and the way that we can look at it is we have 2 times 6 in parentheses to the third power. So that's the same thing as taking 2 to the third power separate times 6 to the third power. So those three properties are what we'll be using and looking at in these examples below. All of example 1, where it says example 1 simplify, all four of these, A, B, C, and D, are product of powers property practice. So we'll be using the product of powers property rule here, the first one. So in this case, we have example A, 5 to the third times 5 to the sixth. So our rule tells us we can add the powers. So 5 to the 3 plus 6, which is 5 to the ninth. Now, if we replace the base number with a variable, our properties are still the same. So we have x squared times x to the third times x to the fourth. So what I can do is add the three different exponents, 2, 3, and 4, which gives me x to the ninth power. Then we have C, we have 3 times 3 to the fifth. Now, if we have a number on its own, we don't write the exponent, but technically the exponent here would be a 1. So this 3 is the same thing as 3 to the first power. So we have 1 plus 5, which would give us 3 to the sixth power. And then in part D, we are dealing with negative base numbers. Still, the rules apply. We just have to keep our negative. So we have a negative 2 to the first power times a negative 2 to the fourth. So we would add the 1 and the 4, which would be 5. So we have negative 2 in parentheses still to the fifth power. Now in example 2, we are looking at the power of a power property. So we're looking at our second property here, and we're going to keep in mind that the rule tells us to multiply the exponents. So if we are looking at this, if we have the same base number, different powers, and it's a power to a power, then we can multiply the exponents. So in this case, 3 to the fifth, all to the second, is the same thing as 5 times 2 for the exponents. So it would be 3 to the 10th. In part B, we have y squared to the fourth power. 2 times 4 giving us 8. So we'd have y to the eighth. In C, we have to keep track of our negative, and don't be thrown off by the brackets. The reason we have brackets is if you have a set of parentheses, there is a general rule for writing mathematics that you don't want to put a set of parentheses next to parentheses, so they use brackets. We treat it the same way as parentheses. So this is negative 3 to the third power raised to the second power. So that'd be a negative 3. And then we have a 3 times 2, which would be a negative 3 to the sixth power. And my negative 3 here should still be in parentheses. So you would want to come in and add your parentheses around the negative 3. Then in part D, in D we have parentheses, or brackets I should say, around the whole thing. Then inside the parentheses, a plus 1 to the second power. And outside the brackets, it's all to the sixth power. So I'm focused on the 2 times 6, which would be the 12th power. So that's the same thing as a plus 1, all to the 12th power. Then in example 3, we are going to be looking at the power of a product property. So in this case, we have different bases being multiplied, but the same power. So what the rule tells us we can do is we can split the numbers. So in this case, if we have 6 times 5 squared, that's the same thing as 6 squared times 5 squared, or 6 times 6 is 36, 5 times 5 is 25, so 36 times 25 is 900. Typically, we do not use this product or power of a product property, I should say. In this case, we would typically use it in problems like B, C, and D more often when we are trying to simplify with variables. So looking at B, inside the parentheses, we have the bases of 4, Y, and Z, all being multiplied. So I can split my 4, my Y, and my Z, and all 3 of those each go to the third power. Then we need to simplify 4 to the third power. So 4 times 4 times 4, which is 64, times y cubed times z cubed. And that would be our simplified answer. In part C, we have a -2 as a base and a w as a base. So when we separate them, the negative goes with the 2, the w is still positive. Both go to the second power. -2 squared is a positive 4. And then w squared is just w to the second power. And in part D, the negative is outside the parentheses, so that will get applied at the end. So we're just going to pull it out and keep track of it. We're going to split the inside, 2 and w, both still go to the second power. So we have 4w squared, just like the last problem, but because the negative is outside the parentheses, we bring that down at the end to make our final answer negative. And then example 4, parts A, B, and C, are a mixture of our 3 different properties. So in part A, what I notice first is I have parentheses 4x squared and y to the third power. So what I know I can do is I can use our third property and I can split those. So I would have 4 to the third power. X squared goes on its own, but then it's still to that third power. And y goes on its own to the third power. And then we still are dealing with this x to the fifth that I just brought down here. So then I can start to do a little bit of math. 4 cubed, 4 times 4 times 4, is 64. X squared to the third power, now we can use our second property and multiply our powers. So x squared to the third, 2 times 3 is 6. So I'd have x to the 6. Y to the third is still y to the third. And then our x to the fifth at the end. Then I can go back to the first property and add or put together my x to the 6th and my x to the 5th. The way I do that is by adding the 5 and the 6. So x to the 5th times x to the 6th would give me x to the 11th. 6 plus 5, 11. I still have my y cubed and 64. So the final answer here is 64, x to the 11th, y to the third. In part B, we have to keep track of negatives as well as a couple different variables. So right away, though, again, I notice I have 3 bases all going to the third power, so I want to split those. So I would have my negative 3 to the third times c to the third times d to the third. So I'm just splitting this piece. Then outside, I still have my negative d inside parentheses squared. Negative 3 to the third is a negative 3 times negative 3 times negative 3, which is a negative 27. Then we still have the c to the third, d to the third. And that whole piece is still being multiplied by the negative d squared. Now, because we have a negative here and a negative here, a negative times a negative makes the whole thing positive. So my negative disappears. 27 is still just 27. C to the third, still c to the third. And then I'd have d to the third and d to the second. So 2 plus 3 would give me d to the fifth. And then in part C, we have 2x cubed times, in parentheses, 3x going to the second power. So because I have 3 and x in parentheses, two different terms, I know I can split those. I can also split my 2 from the x to the third here, just to keep the numbers and variables separate. So I can rewrite this as 2 times x to the third times 3 squared times x squared. Then 3 squared is 9. 2 times 9 is 18. And x cubed times x squared means we have to add the exponents to get x to the fifth. Now, the main thing you'll want to keep in mind as going through these and practicing these three properties is coming back to these three base rules and being careful of the three different properties and what your notations are.